And students from K through 12 can actually register to be part of this. So students and parents, students and teachers, we want to have teams of students clustered together to work as a team, just like we do in this Building 9, building these models, building these mock-ups, building so forth and so on. So if you're a K through 4 student, our youngest explorers, you'll compete with NASA education activities related to radiation. So you'll learn more about what the basics of radiation are, when you take an X-ray, when you do things, when you walk outside for 365 days on the planet, you get about the dosage of about 4 to 5 chest X-rays. So learning about what it means to get radiation in your body and how that affects your body. And so those students will actually be able to do activities, and then their names will be submitted to actually fly on EFT-1. Our 5th through 8th grade middle schoolers, we've added a little more of a challenge. So they'll also complete education activities. They'll have a chance to become honorary crew members, but in addition, you'll design and develop a radiation shield prototype. So that's for the middle schoolers. The high schoolers here, you guys are all high schoolers, right? Okay. You guys look really wonderful out there, by the way. You guys are going to be our engineers in the making, and you'll have a chance to get even more involved. You'll be forming a team, so mentors, maybe from Lockheed, from NASA, maybe your parents, we'll be working together to form a team. There will be 5 teams chosen to test their designs in a virtual radiation simulator. All 5 teams that are chosen will go down to Kennedy Space Center for the launch of the EFT-1, and there will be a final down select of the winning design that will possibly be flown on EFT-1. Now, we're banking on this design because one of you or one of our astronauts will be flying to Mars. We'll be actually using space-certified radiation sensors sitting behind your radiation shield to see how effective it's working at blocking radiation. So that's kind of the big picture of the test. I think about partnerships, I think about community. All the federal agencies are working to ensure that we leverage our unique assets. Orion is a fantastic, unique asset that both NASA and Lockheed Martin are working together to help change the world through this community of learning. Thank you very much. And next, I'm going to invite up Amber Pinchbeck. She's an HISD principal, educator, and an award-winning educator. So, Amber, could you please come up?
Good morning. To reach for new heights and reveal the unknown so that what we do and learn will benefit all humankind is NASA's mission, and to some degree the mission of all educators. For if we do not motivate our students to reach for new heights and reveal something new within themselves, how will we benefit all humankind? As a young girl, my 5th grade math and science teachers, Miss Miller and Miss Richardson, were able to motivate and challenge me to discover my capabilities in these subjects. They even convinced me to be on the school's math and science team, where I was taught how to improve and sharpen my skills, and my confidence soared because of them. And as my interest in math and science grew, I happened upon a movie titled Space Camp, and I knew I had to go. I just didn't know the opportunity would present itself to me as an adult while teaching 8th grade science here in Houston ISD. This is where my connection to NASA and education begins. I traveled with a group of educators from a variety of Houston schools to Huntsville, Alabama, and we embarked on our Space Camp adventure. And boy, was I glad I experienced Space Camp as an adult and not as a child. Not only was it exhilarating to create and shoot rockets, simulate walking on the moon, and take on the role of Capcom during our simulated missions, but I also learned how to navigate many of NASA's resources, including the NASA website, where educators like me can find a plethora of photos, videos, games, and student-centered objective-driven lessons for all ages and content areas. So with my blue jumpsuit, excitement from my experience, and the knowledge to navigate resources, I headed home to Houston to share what I learned with my students and colleagues. A couple of years later, I became an administrator at the same school, and a teacher approached me to apply for an in-flight downlink with astronauts aboard the ISS. With the help of NASA's Teaching from Space department, we were able to host a successful in-flight downlink in our school auditorium. where approximately 20 students had the opportunity to ask questions to astronauts Shannon Walker and Doug Wheelock, while the remaining 1,600 of our students watched live from the classroom TVs on NASA TV. Our downlink was the first step our school took towards implementing STEM objectives: science, technology, engineering, and math. See, my school, Johnston Middle School, is the Performing and Visual Arts Middle School of Houston ISD, and our students are renowned for their artistic abilities. But our students are more than artists. They are future engineers, doctors, and computer scientists, and we want our students to know they can be both. With an auditorium full of over 800 people, you could have heard a pin drop when our students were sending their questions to the ISS. Everyone was on the edge of their seats, waiting to hear the astronauts' responses and watching them utilize weightlessness as they spin effortlessly and flipping, waving goodbye. And the excitement didn't stop there. We worked with the astronauts' appearance office and were able to host Dr. Walker at our school. The days that led up to her visit were celebrated with space and STEM lessons in every classroom, many of them retrieved from the NASA website. The building principal even began calling our campus Johnston Space Center. Through NASA Explorer Schools and the Digital Learning Network, 2 colleagues and I were able to fly aboard NASA's Weightless Wonder and conduct science experiments in micro and hypergravity, collect data, and compare it to the data our students collected back at school in 1G. We've also had the opportunity to work with the Student Spaceflight's Experiments program, where students are challenged to create experiments to be conducted by astronauts aboard the ISS, collect the data, and bring it back to Earth for comparison to their 1G experiments. The impact this project had on our students was stunning. To offer a middle school student the chance to create an experiment and have it fly in space is unbelievable. There are no other middle school science experiments that compare. This is what makes the Orion Exploration Design Challenge so magnificent. Inviting students to assist NASA in solving the problem of radiation protection takes learning and applying science to a new level. It allows students the chance to wrap their minds around a real problem, like a real scientist, and solve and find real answers. Not only is the problem real, but it is also one that will help humans achieve what we have never before achieved by taking us beyond low Earth orbit and onto an asteroid or Mars. Orion is the future of human spaceflight, and what better way to connect the country to this spacecraft than by enticing educators and the next generation of scientists to become a part of its progress and purpose. It is through this partnership that space exploration will flourish and continue to reveal the unknown so that what we do and learn will benefit all humankind. Thank you. I will now turn the event back over to Mr. Leland Melvin.
Okay, so at this time, we're going to have a chance to get questions from the students of this very distinguished panel here. So I would like to bring up the first student to ask your question to the panel.
Hi, my name is Kyle. What do you feel is the greatest benefit of human spaceflight?
You want to hit that, sir?
I can try. I think there are a number of benefits, but since you said the greatest, I think it's an aspirational benefit, and that is one that helps people believe that there is much higher things to attain than what we normally see in our lives every day. I will be very disappointed. I tell people, I came here in 1980 as a brand new astronaut candidate. And when I came, I thought I would fly on the shuttle once and then start training for a mission back to the moon, and then eventually on to Mars. And unfortunately for me and my class, we had something happen in 1986, which was loss of Challenger. And the world all of a sudden turned away from that kind of experience. And it has taken us quite a while to recover. So I would like to help all of you get that dream again, because I know we can do it. But it's something that the nation has to really believe in. Otherwise, it won't happen. So just having you able to talk to an astronaut on the International Space Station, to see that people who are just like you, started just like you, have reached that level of achievement, I think is really important.
Thank you, Charlie. Next question. I think the next question is for Charlie also. Want to go ahead and ask your question?
Hi, my name is Robert Kennedy. My question is specifically to Mark Geyer.
Hey.
What role specifically has innovation played in the developing Orion?
Oh, great question. Yeah, so really we have to innovate in order to make this mission happen. Some of it looks similar to Apollo, but the guts of Orion are really state-of-the-art. So a good example would be the network interface, time-trigger gigabit Ethernet. Allows us to communicate with the computers extremely fast, but also very safe and reliable, which is very important when you got humans on board. We do a lot of things innovating relative to saving money as well. A lot of this mock-up behind you, the stuff inside, is actually designed and built by middle school, high school, college students, because they can provide things that help make this work, also tie education back into the classroom, but also save us money. So it's things like that. It's all sorts of technological and affordability things we need to do to innovate to make this work.
What advice would you give for young women trying to pursue careers in aerospace?
I guess my best advice would be to go for it. I mean, I've been in the aerospace industry for 30 years, started as an industrial engineer so many years ago, and this is an industry where, as you can see, you can be involved in cutting-edge technology and you can work with some of the smartest engineers and scientists in the world. So it's a great place to spend your career. I would just suggest that, there's 3 areas that you should focus on so that you can be successful. What we find is those who focus on doing their best, work hard, and meet their commitments are the ones that are most successful, because we want folks that are dedicated and that are working hard and delivering results. The second thing that's really important in this industry and working with NASA and other government agencies is that you have to be a team player. Everything we do is around teams. It's not individuals, it's teams that make things happen. So being a team player and learning how to work in teams is extremely important. And then I'd say the last thing is you need to focus on continuous learning. Your learning does not stop when you leave school. We learn every day. I learn every day. Those on this panel learn every day. And it's important that you have a focus for continuous learning.
Fantastic. Just go for it. And also check out women.nasa.gov to look at other brilliant scientists and engineers that just happen to be women. Next question.
Hi, my name is Kevin, and what was your first experience working for NASA?
What was my first experience? Let's see. I was working as a research scientist at NASA Langley Research Center. I was building and creating fiber optic sensors to measure strain, temperature, and hydrogen on aerospace vehicles like the space shuttle. And I had never imagined working for NASA. I'd never imagined even being an astronaut until a friend of mine told me, hey, you'd be a great astronaut. And I'm like, me? What are you talking about? He handed me an application. I didn't fill it out. And that same year, our friend, Dr. Charlie Camarda, got into the astronaut corps. And I said to myself, well, wait a minute. If they let people like that in, maybe I could get in too. So I applied to the astronaut corps after that, and it was one of the most incredible things. The outreach, the missions, the training, the teamwork that Marilyn talked about, it all comes together, not just U.S. teamwork, but international teamwork, people working together as one team to advance civilization. That's what we do as a NASA, Lockheed Martin, our contract teams, to change the world. And so that was my first experience, and then my last experience flying in space, and now helping you guys reach your dreams through education. All right, next question.
Hi, my name is Brandy, and my question is, what is your most interesting part of your job?
Okay, you want to answer that?
Sure. The most interesting part of my job is finding new resources to excite my students and get them motivated about learning through STEM, science, technology, engineering, and math. And working with NASA and all the opportunities that they've provided us is very exhilarating for educators and students.
Thanks. Next question.
Hello, I'm Jordan Groom. This is for Charlie Bolden. What is the long-term goal of NASA's deep space exploration?
I think you've heard all of us talk about going to Mars and asteroids, and NASA's long-term goal, our ultimate destination for human beings, and it helps that the president told us to do it, is Mars. And the Orion spacecraft back here, everything that we do today is geared toward trying to get humans to Mars in the 2030 timeframe. So that's the ultimate. Okay.
Thank you. And I think our time is up, and we really appreciate all the participation from the students. Go to nasa.gov/education/EDC for Exploration Design Challenge. This has been a fantastic community helping change the minds and hearts of our next generation of explorers. Godspeed.
NASA is currently developing a new heavy lift rocket to carry a human-rated